This conference will now be recorded.
There are a couple of other things. Then after that, we will try to solve certain things in this thing. There are so many other things in functions, very useful. And also I'll show you, some live code as well in Scala. Might be in the next class. But that live code might not be something related directly to the project or something else, but it will be on that lines, like what exactly the concept we use in a Scala, because it's not possible to share anything part of your project, very well. But what I can help you is at least to get that bigger picture. I can show you something which gives you a broader perspective, like how they are applied in a real use case by changing the code to understand your requirements. Okay, so that's it. So now, shall we continue? So this is what we are doing in the yesterday session, and we stopped till this point with lambdas. I hope you are clear till that. Correct, right? We stopped with lambdas. If you look at this code, what is lambda means? It is a function which is just implemented in a single line, where the syntax of lambda look like this. Very well. It has a syntax like this. It takes a parameters list and then colon, yeah, and it have this arrow symbol. That either it uses underscore or arrow, and then it has a logic here to implement some expression. Otherwise, better to say it as a. This is the syntax of lambda. That is one thing. And then the other part is we can also use the same, parenthesis, then underscore colon, right? Something like colon, some data type, like some var one, some data type, comma, and you close this, some kind of operation on this. Again, a parenthesis, and you can apply underscore and then colon some data type, something like this. See, we can do exploring in different ways. We can keep on changing code, and we can make on doing certain things. Okay, so that's fine. Now let's continue. So this is what we have discussed till yesterday. What is that? Yesterday's discussion is this. But the question is how higher order functions are useful. So I'm taking a scenario, a use case for you to explain what is the necessity for higher order functions. You see this. This is a simple working example for you. This example has both cases. In one case, we take something without we implement a normal function and apply. And in the second case, we implement a lambda function and apply. The third case, directly applying lambda as a parameter itself. I will rewrite this code again, of course. What we are going to do is we will rewrite the code as well. One case one, implementing higher order functions with the normal function, simple normal function. Okay, a normal function, that is one thing. Passing normal function as a parameter, a regular function, otherwise you can say a regular function. Case 2, I am giving you, going a little deeper to make sure you get a better picture. The second case is I didn't implement that, we implemented. Second case 2 is using lambda externally and then passing it to a higher order function. That is case 2. Okay, what is that? Using lambda as an external function. That is one more use case. And third case is case 3 is using lambda directly as a parameter. Using lambda as an implicit parameter to a function. Okay, so So these are the three cases. First, we will observe here, so that definitely I can at least I can say that you will get a better understanding of higher order functions, how they are really useful to you. Okay, this right. I'm taking one collection example. Just observe. This is I am trying to make you understand how these higher orders are useful to you in a real-time use cases. So suppose I take a list here. List is a collection which takes group of values. For now, just remember we declare with a class called list here. L is uppercase, so don't worry much about it. But it can take group of values like an array. If you don't know array, also just remember it takes group of values, and that this is an object where it holds three values, and that is assigned to a variable like this. And here this has an indexing internally. This has an index like it has 0 here, 1 here, 2 here. And if I want to call this, usually I should get like this. First, I'm giving you a quick idea about this list so that it's easy for you to understand like how this list work. Okay. Then I will show you like how to apply a higher order function on this. I will going again. I'm breaking down this into parts here. Okay. First thing, it's like this. What is it now? I want to. This is a list. I want to iterate this list. If you remember in Scala, I taught you how to create a range of values 1 to 10, 1 until 10. You remember, right? By using that to keyword and until keyword, what we can do? We can go for which function, sir? A range function, isn't it or not? Even list is also similar to a range, a collection. It provides a group of values. We can have group of values here. Now, suppose if I want, let me try to print it like this. Usually, we can access a list with index, println of some list of 0. Okay. Use some round bracket. If it is not working, you don't need to worry about it. List of 0. Okay. List of 1. And then list of 2 here. So what I am doing here, observe this. But you can ask me a question. Sir, you are in actions topic. Suddenly you switch it to collections. Why? Because I am going to make you understand like how exactly higher order functions are useful. So before I just switch to that use case, I am building a background to make sure that everybody is on the same page. You understand, right? So that's what I am doing here. Otherwise, again, you have a lot of questions. I don't want to confuse you. So I am building a background so that everybody has a better understanding and in the same page. Now run this. Okay, right click, run as Scala application, and then you get three values here, 1, 2, 3. Can you see here now? So these are values. Then this is an array, and this has three values. The size is 3, and it has index like this, starting from 0, 1, 2, 3. All of you are good till this point. You tell me, all of you are good till this point. Yes, no, sir?
Yes,
Say
sir.
yes, no. Okay, good. Now, this is what if you want to iterate value by value. If you want to print each value individually, independently. But actually in a real time, a list might have thousands of values or sometimes lakhs of values inside that. And you cannot keep doing this. This is very tedious process. And this is not recommended at all. Then what do we do then? All of you know the answer. We can apply a loop on this, isn't it? I taught you how to use the loop here. You take a for loop for some I, right? There is a loop variable and followed by this and then list. Then what can I do? I can say println of I here. Now again right click, run as Scala application. You got it this here, right? Now what I am doing, now I have a requirement. I am showing you now. What is my requirement? I want to, increment each value of list. What is that? I want to increment each value of list by 1 here. Each value. So I have three values. I should add 1 for every value. 2 plus 1, comma 3 plus 1 like this. Then it becomes 2. it becomes 3, it becomes 4. Now I want to do this. What do I do now? For this, the easiest way is simply you can apply I plus 1. Okay. And what it does, it will increment each value of list by 1, no doubt about that. So let me just run this. All of this is nothing too difficult. You got 2, 3, 4 here. Now the challenging part is again I should append all these values to the same list. I want all this to be added to a list itself. What do I want to do? I should add this modified values to a list itself. How can you do that? So there are different ways, isn't it? Now I am not going to use any list methods now, but that is my requirement. So one way is iterating element by element, and we can add that to the list back. Probably we'll check that in collections. I don't want again go to that topic now. But my point is, this is the requirement. What is the requirement? So this is what. This has to become like this, and this values has to be stored into the list back again. You understand this? I'll give more detailing when we go to collections. But do you get this? All of you. Yes sir, no sir?
Yes, sir.
Okay. Now, for that I apply a higher order function. Observe carefully. To do this, I can use a function called map function. Which function? Map, which is present inside list. What is that? It is a higher order function. I'm just introducing a real use case for you, like how these higher order functions are useful to you. Okay, map is a built-in function which is already implemented in Scala in this list class, and this is a higher order function. Okay, what kind of function is that? Higher order function. Now, when it is a higher order function, what is the basic thumb rule of higher order function? What does that higher order function do? It takes another function as a parameter. Will you agree with that or not? We had a detailed discussion yesterday. Now, I want to implement this task, and I want the result to be assigned to the list itself. Okay, it is not necessary to the same list. You can create it into a new, put it into a new list. I don't have a problem. But are you clear till this point? All of you? Yes sir. No?
Yes.
Okay, good. Now we can apply map. It's very easy to apply map. How do you apply map? Sublist dot that reference dot. Don't worry about all this. Just observe. My focus is on making you understand the importance of higher order functions, not collections topic. Collections we will do far better than this. We will take so much of time, and we will dig into the collections. This is how I call this map function, and this map take a parameter, and map itself, let me tell you what is this is this itself is an iterator by itself. Map is an iterator. No, it will take a value by value until the end of a collection. Suppose 1000 values are there, it will automatically iterate 1000 values one after the another, one after the another. For 1000 times it will iterate internally. You don't see all that. There is a lot of logic going on in this higher order function, but you don't know that. But what you see is it is an iterator. What it does, it will iterate. It is an iterator. Iterates element by element. What it does, it iterates element by element. Observe carefully, sir. If you don't understand, ask me. It iterates element by element. Okay. And applies a logic on each element. A logic. And performs a transformation. The exact technical word is and apply a transformation. Listen carefully. A big transformation means some kind of mathematical logic, modifying the existing one. Suppose here 1 became 2, 2 became 3, 3 became 4. Is it a transformation or not? Are we changing a value to that or not? That's what we call transformation, and apply a transformation on each element. Do you understand this? Now my problem is this: I want to iterate this list and increment each value by 1, and then I want to return and initialize back to the list itself. It is not necessary to be the same list. It might be a new list if it is required. Okay, so now what should I do then? So that's what this does, map does. But this map takes a parameter as a function. It takes a parameter as what, sir? As a function. Okay, are you following this? Now you will see, sir. So I have a map ready here, map ready, but I need a function to apply some transformation in that map. That logic you have to pass, sir. That logic, whatever you have to pass to this map, will be in the form of a function. So what should I do now? Now I am doing first case. What is that? I am creating a simple normal function, and I am going to pass that normal function to this higher order function. So how do I do? Here you are not defining your own higher order function. It is already there, sir. Your job is just to define a function and call that function through this map iterator. So how do you do that? Define some. This is like a simple addition only, right? You can say something like some add 1. Okay, I'm adding 1 to each value, right? So I'm just making it as a add 1. Okay, and it takes one parameter, a colon int. 1 is enough, sir. And then return type of this is what, sir? Int here, and then assignment return this. Okay, then what do you do right now? You say a plus 1. Every time a value comes to this function, you will add 1 to that and you will return that result back. Are you good till this point? Are you good till this point, sir? Now I have to call this a function from this higher order. How? Observe this. Now here, more or less, when you are calling this function directly, it will be like this. How? Like it will take a function like this, some x arrow mark, and then what you have to do? Internally, of course, it takes a lambda as obviously it will always take a lambda as parameter internally. But I'm just showing you how this works. So x is a parameter which is used to hold. This is a dummy variable, sir. You have idea about iterators. I taught in Scala. You remember, right? For iterator, you say for I something like that. X is something like that only. It is a dummy variable. Every time map iterates, one value from list is copied to this x. On top of this x, I need to do some. I need to add some functionality. For that, I am taking the help of this addOne. So this is the parameter which we are extracting from the list, and that we pass to a function which is at the right side of the rocket operator. Are you following, sir? It is at the right side of a rocket operator. Here at the right side, you can apply a direct logic, or you can call an external function or external lambda function. Now you see, I say here addOne of I just pass x here. Now what this does. Now the error is completely removed. Till this point, you are seeing some error at that line. When I don't use this, you can see an error here. Can you see this? But as soon as I have called a method at the right side of this rocket operator, the error is gone like that. Now what this list does, what this map does, this map will iterate this list element by element, starting from 1 to 3, and then it will do all things on its own. It knows where to start, where to end, and how to iterate one by one. Everything is internally implemented for map. You don't need to care about it. Okay, that's an iterator by itself. Now what this map does is, it just not perform iteration of element and apply some logic to an external function. So what I'm doing, every time map iterates, one value is extracted to x. and that x is passed to this function addOne. Then the control from here goes to this regular function, and this regular function performs addition of 1 to that, and that value is returned back to the map function itself. Now what map function will do? It will collect all the values. So you are passing 1, you are passing 2, you are passing 3. Then for first time, it will take 1 and pass addOne and extract that result and keep it in a buffer. It will pass 2 and perform logic and keep it in a buffer. And it will pass 3, perform logic and then keep it in a buffer. And all these values are put it into a temporary buffer in the form of a list. Okay. And that is written back. You say something like some var, okay, some x equal to, already x is there, I don't want to confuse, some values equal to, okay, I say this. Okay, now what happens here? This map performs transformation on each element. Transformation is what? Transformation is applied whatever the function you have implemented, this logic is applied on these elements, and all these are collected in a internal buffer or some kind of collection internally. That is probably a list. Here if you put a cursor here, it will show you what kind of value finally it is returning back. It will return, map returns a value of a list. Here can you see all your results are collected into a list, and that list is returned and assigned to the values here. You know, function return a value, right? So map itself is a higher order, sir. Might be you can ask me, sir, I didn't see that f colon a comma b and then arrow mark any value here. That is your own higher order function. If you are creating your own higher order function, you have to define in such a way that it takes some parameters and apply some kind of processing and then return something. But this is already implemented by someone, so we need to understand the signature of this and what to pass to that and how to apply this on some functions. That is what we need to understand. Now this is higher order. Now I'm just printing this. I think all of you got clarity here. Do you understand, or any doubt on this? Still anybody has doubts on this? This is how higher order function works. It takes a function as parameter and applies some logic transformation, and then that transformation is finally applied to the values and finally return that result back for us. Let me run this. Right click. Can you see this now? Again I am getting a list, but is there any difference between this list and the output list here? Yes sir, tell me. I thought to teach you this when I moved to collections topic, but as I am seeing that this higher order functions is a bit not clear to a couple of you people, so I want to make it clear to everyone. Do you understand this now? Yes. Still, if you have questions, ask me. What I am doing now? What I am doing now? I am doing some transformation by applying higher order function, which takes parameter as what? A function. Now this is a normal function. Let me convert the same function to lambda. We can also apply lambda function like this, sir. Observe carefully. I can make lambda like this. This is called partial functions as well. What functions, sir? df addOne equal to something like a colon int arrow mark a plus b. Okay. Now you can see it's almost same. What is that? I just removed my block here, this opening closing braces, sir. Okay. Second thing, instead of taking parameter with the function, I moved it to a lambda approach here. Can you see this now? But still that def keyword is there with the, can you see this? You can still find the def keyword with this variable name. Why? Because such functions we call them as partial functions. Still It uses what? Lambda here. Can you see this? I taught you the lambda syntax. Parameter list bracket followed by expression. Same function, we just made it a single line instead of having 3 lines. Now you don't need to make any change to this code. Now you pass this function name as this higher order function. Now you run this program, right click, run as Scala page. You got same output or not? So this is case 2. From case 1, having from case 1, having a normal function, I modified it to you can call it as a lambda or a partial function. Now this is case 2, but I didn't make any change here because the way we call this one is also same here. That doesn't change. Next, third case. Are you good this till this point? You do one thing, sir. First you test this. You test, all of you test this example. Please test this. Test this example, sir. We are applying something with it. You see, mostly problem with Scala is most of the examples, if you want to get from internet or some YouTube channel, it's not that easy, sir. I can tell you this. You don't have too much of documentation. You don't have too many simplified examples in the internet. This is my gut feeling, okay? Because when I explore, we come up with things with lot of difficulty there. So what I suggest is focus. You want me to share the code? Okay, no problem. If you are copying and pasting, no use. See, you have to type it. Then you understand something there. Madhu, may I know what is your state of mind right now about higher order functions? Probably I have took this example keeping you as my primary this thing, because you, as in our discussion yesterday, we came up with a point like, there is a bit of confusion here. Why we need higher order of functions? Why we should pass a function to another function? Then it made me to think like, okay, let me make sure you get some good idea. Okay. And even you have Akhilesh here. He knows the importance of Scala. He is actually working from Visa in US. What do you say, Akhil?
Yeah, sir. I'm following it. Yeah.
Today itself we learned functions topic. So this should be more helpful for you to understand.
Yeah, definitely.
Yeah. Once you finish, anybody just update me if it is tested. Then we will move to the case 2 and then case 3. And I hope at least by the time you should get some idea. Okay. Take a minute and test it, sir. Is it tested, all of you, sir? All of you tested this? I got 2 answers. What about others? Finished it? Yes, no, doing, want some time? Okay, let me go to the case 2 now. With a lambda or a partial function. No, we can also define a function like this in a line like this. Now this is a bit, you can just remove that braces as a block thing. And what you do is, you just see how I am just modifying it. And here apply a bracket between these two. And you leave it like this. You can put def here, or you can declare it as a var. Even if you put var here, it will work, sir. Even if you put def here, it will work. Difference is, if you declare it var, it becomes a pure lambda. If you put def, it is a it's a partial function. It's not a, what do you call this? Such kind of functions, technical in Scala, they call them as partial functions. Okay. So nothing to worry. Still, it's a lambda only. Now you can call, even if you put var, you can call it in the same way. You can put def. The way you call it in the higher order function, it is same, sir. It doesn't change. This is case 2. Test this, sir. All of you understood this, right? I have explained this use case. And you know, if you have attended yesterday's session, I hope everybody attended this. So probably you don't have any confusion on this. This part everybody is clear. The left part usually we put var here. We have done this yesterday. This is a lambda function as a whole. And you know, when you are calling it, you should call by the variable which is pointing to lambda. And if lambda is taking any parameter, through that variable, we have to pass parameters. Yesterday, I have given a clean discussion to this. Okay, we can do it like this. This will work. You can right click and just say run as Scala application. I'll give one task after this. Be ready. You are going to work on one task, sir. Then automatically you'll get some idea about higher order functions, even if you don't want. You have to try it yourself independently. Then I put def here. When I run this, I get the same output, sir. Can you see this now? So this is case 2. Okay. All of you tested this now? Keep testing with me, sir. Okay, next one. Third case. Suppose, you know, let us see the power of lambda. I'm removing all this. This is case 3. When you go for lambda, you can just directly pass a lambda as a parameter to the higher order function without externally declaring any function. How? You know, right? The syntax of this comes like this. You remove this, just you can say apply direct logic here, sir. You can see. Can you see this now? You can apply direct logic, and this is as a whole a lambda. Okay, can you see this? This bracket itself denotes lambda here. Now, no externals. How lambdas are useful? Now you see your code. Now you see a lot of difference in this now. The optimization had gone to the very least level here. Okay, now when I run this, still the output doesn't have any difference, but the energy we invest here is going to be reduced. The burden on us is going to be reduced. Can you see this? How simple it is when I go for lambda? But still it is a higher order function. It takes a function as parameter. Many people don't understand this. If you don't clearly know that this is a higher order function. Now if I can show, I'll show you. Are you good with this? Test it now. All of you test it once. Then I will show you. Lot of higher order functions to you. Test this case 3, sir. We keep updating this document. It won't be the same version. It keeps changes time to time. Okay, we just test it, sir. Meanwhile, I'm just adding this code to the document so that next time I don't need to refer the whole internet if anybody asks me a doubt. Okay. You don't need all this, sir. I don't like this. I just want something simple here. Simply, what is that? X plus 4 over. Simple, right? Now I'll give a small task to all of you. Are you ready to do this? Will you guys do this now? Madhu, what do you say now? How is it? Still that higher order is making any confusion? Or shall I give one more example on this? Okay. So I thought to introduce all this in collections, but I don't want you to wait till that time. And you see here, guys, observe here. I'm just going down here because I have this Spark coding at the bottom. So you see here at Spark. Somewhere I put some Spark code. Otherwise, no problem. We have Google, right? What else we can do? Sample Spark example. Now you see here, you see lot of example with the Scala. Just observe this example. I don't want you to understand this code, but I just want to understand the functions that we have in higher order function. We have in this Spark code. This is Spark, simple Spark code. Okay, I'm adding to my as the end of this functions, so that next time, what is that? It's easy for me to show everyone. So much of Scala is there, sir. Because if you can master Scala, there is nothing in Spark. If you don't master Scala, even Spark becomes very heavy for us. So this is where we are. And even at the same time, you can master much more of Python also, because Scala and Python a bit look similar. Now, look at this code now. Can you see this? This is in Spark actually. This is actually a Spark code. Okay. And in Spark, you can see these functions: flat, map. Okay. All these are what is that? Functions, higher order functions. Flat map is a higher order. It takes lambda as an input. I think this is actually the 1 minute. Should be a. I'm assuming this should be a Python code. See, can you see this now? Showing Python, yeah. Because I even know a bit of Python. So let me take Scala here. I cannot explain Python for Scala. It's totally a wrong choice then. Can you see this now? Now you perfectly see this. This is higher order function. This is higher order. This is higher order. Everywhere you find lambdas internally. Every higher order function. Can you see this? Can you see this? Instead of lambda, you can go for a normal function. But writing a function and calling it here, that is much more tedious thing. Very difficult process. Applying lambda make it much more easy, much more simpler and faster and quicker. Can you see this now? So all these are higher order. And in this way, when you go to the Spark, majority of the functions we apply in Spark are higher order functions, which takes parameter as a function itself. Do you understand this? Might be if you ask me a question, why should I learn a higher order function? This is why you should learn a higher order function. Okay. So I will give a small task to you. One more example as a task. I am not going to implement another example. Okay, you implement it. Already I have given. We have had enough discussion about higher this real-time use case and a higher order example. Might be now you can understand how these higher order functions might be implemented. Even you can go and dig it deeper. What would be the syntax construction and how this parameter might be declared in that map function. Even you can go and look at Scala is open source. To go to the code, this map implementation code, that open source code, still you can see a lot of things. Now, if you have understood how we have learned this higher order functions, the parameters, all that, then it's easy to go and look into this code. Tomorrow in future, somewhere this helps you in debugging. Understood? That's the point. Now, another example, sir. Write a program. Take a list, sir. This is my list. Take some random data, some var space, some list equal to list of some. What do? You take something like 2, 3, 4, 5, something like this. Okay. You use higher order function map itself. Now the requirement is write a program. You can take the input as this. Write a program to print all even numbers. To print all even numbers from a list into another list. To otherwise to copy to copy all even numbers from a list into another list. Try this now. This time you can apply which one? A higher order function map. Apply map and try this. There are how many here? 1, 2, 3, 4, 5, 6. Some are even, some are odd. I need all even numbers into another list. Try this. Means 2, 4, 6 has to be copied to another list. Will you try this? All of you test it. Use which approach you want. You want to take a function and pass it as a parameter, or you want to take a partial function and pass it, or a lambda to be passed it. Whatever you want to do it, sir. I have explained all the different 3 to 4 cases. Right. Akhil, are you following? Because I believe you missed the lambda topic.
Yeah, sir, I'm following. I'll actually be up to date from the next class.
Yeah, sure. I will share the videos as well in the YouTube. Vijay, how is it for you?
Sorry, I'm fine, sir.
Okay, thank you. Madhu, I think now you should be good. Tell me if you are not good, then I will definitely make sure we'll get more examples. Still, anybody has questions, please raise the questions. I'll try my best to answer your questions. If not, we can discuss again. So did you try this, sir? All of you finish this program? If anybody has finished and tested, just tell me we have finished that. Done, sir. Done, or sir. And I request again, I'm requesting, please, your bytes are important for us. We are planning a promotional activity, so it might help us. So this is a request from our side. It is just a bit of a minute or two, that's all, not more than that. Shall I implement this now? We want some time. Do you need some time, or shall I go for solving this? Okay, fine, no issues. Any one of you other than Vijay and Akhil and Madhu, any one of you are into any big data practice? No, my question is not about doing practice about these classes. Big data practice is working on big data. That is my question, Bharat. Anyone working on big data projects or a big data consultant? Other than Akhil and Vijay and Madhu, because they were more into that area. Okay, fine, no issues. I'm just only asking. So I'm doing this example. I think you have enough time to test it. Shall I? What about Vinod? What about you? Shall I do it now? Okay. Take some elements. Some 1, 2, 3, 4, 5, 6, 7, anything like this. Leave it like this. What shall I do now? I just need to say x percentile 2. Shall I say equal to 0, or shall I just leave it like this? What should I do now? It will just test it. So should I say here equal to 0, or okay. Yep. Now let me run this. Okay. What I'm getting here is I'm getting false, true, false, true, false, true. But in place of that, I need values. 1 minute. Let me try this. I'm getting reminders. That is fine. But what if I should get a number here? Equal to 0. X. I can apply some conditions here. Let me try a condition. X percentile 2 equal to 0. Return X. Let me just work on this. Perfect. But I'm just still getting tuples here. Can you see here? No, when the condition is false, I'm getting something. I don't want that. Then else, what I can do? I can simply just skip it. So skip what can apply. We can write like this, sir. Condition check also we can do. We will explore more on this. I don't want that parenthesis to be there.
So space.
Okay. What space? 1 minute, 1 minute. Just check. Don't need empty brackets. I'm getting partial output, not the perfect output. Uh, 1 minute. Let me. As a developer, we don't generally by heart things. Even numbers in lambda Scala. I'm asking in Scala, not in .NET parallels. Okay. Not this. This is actually okay. Yeah, it's doing this. It should work, right? I implemented the same. Why it is failing here? I say X percent file 2 is not equal. It's giving me the output, but I'm not satisfied with this output. What I need is, I don't need true false here, but what I need is I need values. It's giving me what is true, what is false, but I'm expecting. This is fine. The other one is also fine, but still. Okay, I will check and update you guys. I don't want to waste your time here, but this is one way, that is fine, and also applying some condition checks. If is also fine. There is another way. We can also take an if and then we can just return like this. This is also fine. Okay, but this is not the right one, because still we are seeing some tuples here. These are called tuples with these empty brackets. We'll talk more on that when we go to collections. Anyhow, this topic is more on concentrating the higher order functions, just to get some idea about how higher order functions works. We took this example. Okay, is it fine till this level? I will update it in the next session tomorrow. Maybe if you want numbers, but we do lot of we solve lot of this kind of examples in collections, so that let's keep it for collections. So when we move there, then I will make you to work in all these kind of more samples. Fine, right? Can you see the above code? Somebody had given me some output. Yeah, using function is fine. No, that is fine, Suresh. Without that, I'm checking with lambda. Do you get it right? I'm checking with lambda, only lambda. Okay. Okay, guys. get us some more examples to work on weekend. You can just try Google it once, Bharat. Okay, just try to get it. Practice exercises on Scala functions. You can find many problem solving exercises. Even with function getting same mode. Don't worry about it, Veera. We will fix it in the next session. Okay. Clear? Nothing to worry. We'll get it. But the point is not getting into the heart of this collection topic, but understanding how higher order functions works. We will do it. No, not an issue, Madhu. Okay. Maybe we will check this. But this is more of a collection example. So, but our focus is more on what? Understanding higher order functions. Okay. But still we will fix it in the next class. Nothing to worry. Okay for all of you? Okay. This I will fix in the we will fix in next class, sir. But before, apart from that, now do you get a bigger picture about this, sir? Lambda functions or higher order functions, or how it is useful to us. Now do you get a bigger picture now? Actually, I thought to complete all this, but somewhere when I listened that Madhu is having a confusion. Might be the same confusion is there for many people. I thought to first give you a better picture. So we worked on it today. A workaround for higher order. No? The next session we do all this. Clear, right, sir? So what I request is, sir, I am seeing, see, somebody is coming and somebody is leaving. I don't mind like that, but please stick to the session. That's what I request. Okay, if you want to, if you have some network issues, that is not a problem. But if you want to withdraw in the middle or at the somewhere in the middle of the session, please think about it, sir, so that it won't distract my attention or somebody's other attention. That's good for all of us. Clear, right? Any questions? Do you want me to spend some more time, or shall we stop here? Already it's 10:30. Okay. And somebody is asking more examples on this. Sir. You can do one thing, sir. You can do one thing. For functions, you can implement all this C patterns if you have patience. C pattern. I'm talking about functions, not higher order functions. Higher order, when we go to the collections, I will expose more onto all these things. Not now, not necessary at this juncture. So here, this is something which I suggest for most of the people who wish to do coding to improve your logical foundation. You try all this with functions. Okay. You have something here, right? Implement every pattern with some function and see wherever you need, you pass parameters. Suppose you need 5 rows, make that function takes one parameter where you pass a number of rows to print it. Okay, and you implement all this number patterns, star patterns, all this. You are asking me some exercise, right? Rewrite all this with the functions. A function should implement some pattern. Okay, this series, you try to solve this series, and if you can solve all this, definitely you will be another level of programmer, no doubt about it. You will be something else. Okay, I suggest this for most of the people, and I have solved most of these patterns. Okay, I'm not saying that I am something here, but only point is that helps you. Clear now? So until this first 4, you try to implement with functions in Scala. Bharat, I think this is more than sufficient for at least for 3 to 4 days, if you spend at least per day some 12 hours or 13 hours on each pattern type.
Yes, definitely.
This would be helpful, Bharat. Please try this, okay?
Sure.
So in Scala, they are in C language. When don't copy, try to implement yourself. Okay, whatever you can
Right,
solve.
right.
Okay, is it fine, right?
Sure, it's fine.
Correct, Veera. Yeah. Map will implement. That is what the behavior of map is. It will iterate each element, no doubt about that. Each element. But if you want to extract only even numbers, we have to check. There will be a way for every, for every problem to get some proper solution. We have a way for that. I will check and update in the next session, probably on Monday. I will update it. Okay. Because we don't generally take same examples in every session, or while working, even we just try to understand the logic and leave it like that. So that's why, don't worry, I will fix it in the next session. Clear now? Okay guys, see you.